So, thank you for inviting me to the conference. My name is Kladko. I'm Chief Technology Officer and co-founder of SKALE Labs. SKALE is a network of high-performance blockchains, which are EVM compatible. We launched about 4 years ago. Now we have about 2 million transactions per day on our network, and it's growing really fast. We have some really cool games, and also we have some really cool and useful AI applications on our network. And I would like to start by just thanking the organizers. I think, Lisbon is becoming really like a center of crypto. And I know some people are moving from the States. In our case, what happened was that SKALE was always like 2 pieces. We had the business part, which was in San Francisco. And most of the core technology team, core engineering team, we were in Ukraine. We kind of like to be in the same room. We like to have like small number of engineers working really hard. Like Telegram has like 30 engineers. We have 15, so we have probably too many. Don't have to have many engineers to create a great product. But we were working in Ukraine, and then now working in Lisbon. So we moved here to Lisbon. We have now here in Lisbon about 15 people. Engineers with their families, and girlfriends and boyfriends and whatever. So we're actually sitting in Atrium Saldania, in the co-working space in the Atrium Saldania. You guys always, those that live in Lisbon, always welcome to come talk to us. Again, thank you so much for the organizers. I think this conference is really, many people want this to happen. So I want to talk about something that, like, the next big thing for us at SKALE. Engineers always want to do something interesting, and just we're looking for something kind of for us to work on and something which makes sense. And it's actually not so easy to find something that makes sense, especially in the crypto industry. So we kind of thought for a long time, actually we had different directions. And basically after long thinking, like in the previous year, we kind of decided to make this big jump. And so this year we're going to be transitioning SKALE to really something really new and interesting. And this is something which is called a fair blockchain. We call it fair blockchain. And I'm going to tell you guys a little bit about what is a fair blockchain, how we see it. So this is actually this is my ChatGPT creations. Actually, it's all created by me and ChatGPT. So this is how normal people think about blockchain. The funny thing is that I think people think really great about blockchain, but they don't like crypto. Crypto is supposed to be bad and blockchain is good brand. So people view blockchain as something really nice and hippie, like a paradise of actually, and actually we probably can use the word fair. That's like fair. It's a good word for blockchain, right? And I think Alex, the previous speaker, he asked you guys how many of you guys use centralized exchanges, and you raised your hands. Maybe if anyone ever used a decentralized exchange, please raise your hand. So this is pretty like a professional crowd. But if you look at decentralized exchanges, they're actually the users is really not so much. Most of the volume in the world happens on centralized exchanges. And so that's kind of what normally think about blockchain, but if you start using it, that's what you get, that's what it actually is. And so people start using blockchain and they start using decentralized exchanges, and most people don't know how it works, right? But what you find out is that on decentralized exchanges you usually get like much growth rate, and you kind of somehow the money goes away. Basically, if people get back to centralized exchanges or centralized applications, it turns out that the problem is that, you look at Ethereum, for instance, you can look at other blockchains, but you look at Ethereum and you have these things where, there are lots of companies and people and block proposers and industry insiders, and some really cool mathematicians and AI guys. And so when you submit a transaction to Ethereum, you think it's like, the previous slide, but actually you have this really important, interesting and talented people analyzing the transaction using AI and trying to make money. And you have this feeling that you're like losing money, but you don't actually understand why. So you have these lots of things on Ethereum and other blockchains happening where when your transaction goes to the blockchain, as I said, it's analyzed and it's milked, it's actually compromised, it's used, and all kinds of things. So what is maximum extractable value? That's exactly what it is. Maximum extractable value is additional profit that miners, validators, or other actors can capture by reordering, inserting, censoring transactions within a block. MEV extractors profit at the expense of regular users. It's like $1 billion, no one knows how much is it, maybe it's growing really fast. So pretty much anything in the blockchain, like exchanges, prediction markets, and lending protocols, you name it, oracles, pretty much anything where you can make money, when you submit a transaction as a regular user, it doesn't actually go immediately to the blockchain. It goes through this kind of companies and auctions and smart guys and AI and everything. And you as a user never understand it. But the only way to see it is that your exchange rate, as I said, the exchange rate on decentralized exchange usually is way worse than on centralized exchange. So why is it even possible? So it's possible is actually because users, when you submit a transaction, it's plain text, right? And it's not executed. It goes to the memory pool. You think it's going to be executed fast. In reality, these people that actually want to stick something in front of your transaction, censor it, reorder, whatever. But the point is that they want to do their transaction, so to do whatever they want to actually use your information. It's a very generic thing, right? You're doing something, you're submitting your information, someone can use it, and that's what they do. And so MEV extraction shifts power from users to a handful of insiders, smart people, miners, validators, and bots, by enabling these actors to exploit their privileged position in the blockchain ecosystem. And I'm not against people making money, it's good to make people rich. But the problem is that when this is all happening, regular users, actually, basically the money is getting milked from them, and they go and use centralized exchanges, centralized solutions, you name it. So we at SKALE decided that's a very important thing for us to solve this problem, and then we introduced the notion of this fair blockchain. The fair blockchain basically want to mathematically prohibit the things from happening. So we want to have a blockchain, modify the actual native blockchain, so this MEV extraction is mathematically impossible to do. So that's the name of the protocol. The name was actually, the acronym BUIDL was produced by ChatGPT. I would like to thank ChatGPT for this. It's a great acronym. Actually explains what the thing is. It's blockchain integrated threshold encryption. It's a protocol. It's something that we stick into blockchain to eliminate this MEV. And so the way we see it is that Bitcoin store value was the first blockchain. Ethereum made blockchain programmable, but it is incredibly slow, Ethereum, right? And Solana made it fast. And what we want to do with fair blockchain is to make it fair. So we want people, the regular users, feel the same as big guys. And even on centralized exchanges, you can take like New York Stock Exchange, or you can take NASDAQ. Some of the things that MEV extractors are doing would be actually criminally punishable, believe it or not, on centralized exchanges because there are regulations on Wall Street. What you can and what you cannot do with information. So we want to basically do this. And so how we want to do this? It's actually a very simple idea. So you have your transaction and you're sending something to Ethereum, and then you say, I want to exchange this token for that token, I have this number of tokens, I have whatever price. And usually when you do plain text, people just explore it and exploit it. But with this, you want to encrypt the transaction. So when you submit your transaction, the important thing is this something which is called smart contract inputs. It's protected and encrypted. And so when you submit, it's encrypted, they cannot use it, they cannot analyze it, but then you have to somehow decrypt it, because you cannot need to actually execute the transaction. And then there's this sweet spot where you decrypt the transaction very, very late. Basically, that's the entire idea. You decrypt it super late, so it's already on the blockchain, but it's not executed yet by the EVM. So because it's on the blockchain and it's committed, it cannot be front-run, it cannot be reordered, it's already there. But because it's not yet on the executed, you can still decrypt it. And so actually, for the EVM is very transparent. You don't need to change solidity, you don't need to change EVM. Everything becomes actually magically MEV protected when you have this blockchain. So literally, you can take MetaMask, you can take whatever, and things magically change in the sense that you cannot really have MEV extraction. So that's the property, MEV, free. Provable resistance for MEV and front running. So we enable users to submit encrypted transactions to blockchain. Censorship and NVIDIA extraction are fully eliminated, since the content of transactions is protected from block producers, NVIDIA bots, whatever. The transactions are then decrypted, as I mentioned, using this really cool algorithm. I'm going to talk about it. It's a decentralized decryption algorithm, which is called threshold decryption, and it happens after the transaction is in the blockchain. The apps get magically resistant against censorship and NVIDIA. No code changes. Users enjoy free versions of DeFi applications, Uniswap, Polymarket, you name it. You literally can like fork Polymarket and Uniswap rather than this blockchain becomes magically protected. And then it's also MetaMask compatible. You don't need to change MetaMask, you don't need to change any other wallets. Basically, you keep whatever you've been using, all of the Ethereum infrastructure. So let me talk about this really cool thing, which is called threshold encryption. So basically, just to explain how it works, usually when you encrypt, you have a key, like a public key. You encrypt the public key using public key, you decrypt using private key. That's how people usually do these things. Right? But with threshold encryption, you decentralize decryption. So normally, a guy or a girl decrypts. Now you have many people that they have to come together to decrypt. So let's say you have a committee of 100 people, 66 of them need to get together to decrypt things. Another way to view it is it's like a multi-sig but for decryption. So it's multi-sig, if you have 100 people, you're going to have like a 66 people multi-sig, 100 people 66, they come and like do the multi-sig, right? The same here, to decrypt, you actually have to have a number of people to get together. So even if some of them become malicious, it doesn't really matter. A big number of nodes of people, computers, need to become malicious. And then when they decrypt, when the good guys decrypt, they all of them create these like small pieces, and then the pieces are built like a jigsaw puzzle. This is basically, the guys are hobbits, the nodes are hobbits, or whatever, the gnomes, and they all do their own small thing. And ultimately, they group this thing together as a jigsaw puzzle. And so that's a paper that introduced this threshold encryption. We're using the variant which was created by Dan Bonnet. There is a mathematical thing which is called BLS. So we're using this mathematical paper. We implemented this. It's open source. There's a library which is called libBLS. It's a SKALE library. You guys are welcome to use this library, and it implements this threshold decryption. And by the way, another cool thing is that when you have this like threshold decryption, you have this decentralized decryption, you have this kind of special keys for it, which are called the threshold encryption keys, and they are not regular keys. They're like cool keys. But to create the key, you have to have a setup procedure where it only needs to happen once, where this committee, this group of people, exchange messages, like broadcast messages to each other, like shout to each other in some special mathematical way. And when they complete this procedure, this DKG, magically they have the keys. Once they have the keys, then they can use the keys for decryption. So for this particular phase, for the setup phase, there is another paper. It's an algorithm which is called the Joint Feldman. This is the paper that discusses this algorithm. It's a pretty cool algorithm where you actually can create this really interesting threshold decryption keys. Okay, so that's actually the kind of the secret sauce, that's what we are doing. So essentially we're taking blockchain and like digging really deep into blockchain. We're not changing any of the layers above. We're taking the Ethereum compatible blockchain as it is, and like going really deep and like changing things deeply. So users won't actually know, and even the developers won't know. The same solidity, the same EVM, the same MetaMask, whatever. So this actually takes lots of like energy and like coding. But the point is that it's the sweet spot. I say that the key idea of this protocol is the sweet spot. So there is EVM and consensus. So typically you have a blockchain consensus, you have blocks, they're proposed, then they're finalized. And they could be finalized in a different way, but once they're final, that's it. They can't be changed, right? That's why the word finalized is used. So when consensus finalized a block, right? But the EVM is not yet executed the block. We actually stick this byte protocol that decrypts these important things that were protected before. So on the right side, the things are still encrypted, and in the middle, they're getting decrypted, and the decryption also happens through some kind of like a shouting, like network broadcast things. There's a protocol where the nodes, the committee members talk to each other, and they decrypt the transaction. And then that's it. And then happily, at each node has the transaction decrypted. At that point, it looks exactly like a regular Ethereum transaction. It can be viewed in a block explorer. You won't notice it was actually encrypted. It's very deep inside. And then that's it. And then you can basically take Uniswap and you run this Uniswap on this blockchain, and it becomes magically EVM protected. You can mathematically prove that you cannot do actually any extraction on this blockchain. You can take Polymarket, you can take any lending protocol like Oracle, pretty much any DeFi application, and then you get this magic property. Yeah, and that's actually what we do. Just to go a little deeply, there are actually 10 phases of pretty much any probably secure blockchain. I don't want to go into much details. We actually have some videos on YouTube where we explain what are the steps for probably secure blockchain. But basically there are 10 steps. And so where we stick the BUIDL protocol is essentially making step 8.5. At step 8, the node, like a party to a blockchain protocol, already has the block. And the block is finalized in some way, so it could be like signed using a supermajority signature in some different way, but the block is final. And then step 9 means execution of the block, and that's where actually we stick this BUIDL protocol. So actually the actual implementation, some of it is already on GitHub. It's in beta, and we're planning to release the beta to people sometime in the first quarter of 2025. And then the entire end of 2025, the entire year of 2025 is going to be for us actually plugging this protocol everywhere, essentially. And that's what happens at the level of the software. We have, you can have a guess. We have like our C++ client and plugging the BUIDL protocol here. So let me conclude. So we have this thing, which is a pretty cool thing. It's BUIDL protocol that cheats any free property by encrypting the data field of Ethereum compatible transactions. Since the data field is encrypted, any extractors will be able to analyze from transactions. And this ensures that DeFi applications are probably free as long as there's a large number of good guys, right? If there's like a couple of malicious guys, it doesn't matter, right? As long as like supermajority of guys are good guys. And so for some of you that know a little deeper about this, because other elements of the transactions, like source address, destination address, nonce, gas limit, gas price, you name it, all these other things actually are unencrypted, remain unencrypted. The protocol stays ETH compatible. So there's gas price, the EVM doesn't notice. And so that's kind of what we have. Our plans for 2025 are like basically add protocols to the existing SKALE chains. I think we have 400 chains now, but since our current chains are mostly gaming and a little bit of AI, we also consider running specifically new DeFi-focused chains or chain that would actually implement the BUIDL protocol, because we think that it's really something that makes sense to people. Yeah, that's it. And I would like to again thank the organizers for the. I think I think Adrian. I don't see Adrian here, but he mentioned yesterday that very few blockchain conferences make sense. I think ETHCC definitely makes sense. I hope that this conference will also continue like it is, so there are more people. I think we just have to keep like small number of people. But I really enjoyed meeting all of you guys yesterday. And, I think it's a really good conference. It's the first conference.
Thanks a lot, Samuel. We have a few minutes for questions. Are there any questions in the audience? Just get a few more.
If the source and destination addresses remain unencrypted, how does this protect against censorship? For example, when an address is blacklisted and no one wants to mine their transactions.
That's a really fantastic question. That's actually a choice which we could make. We could easily make the destination encrypted, because because of the gas fee, you need to know the source, right? The destination does not need to be known. Frankly, when you protect things too much, you become like Monero, and then you will get delisted from exchanges, and like it's really private blockchain, but you have to fight the government. And the question we're asking ourselves: do we want to be like Monero, or we want to be more like immediate protection? So if we don't encrypt these things, then there's still some possibility for censorship, which could be avoided. You could like use a temporary addresses, but we don't get into fighting the government because it's a choice for us. Do we want this to be an MEV-free thing for DeFi applications, or do we want to be more like Monero? And then
Thank you. Are there any more questions? If not, then please give it up to again.